All right, so let's start, okay? And so yeah, for this formula, okay, so yeah, if you use the method one, okay, so most time the students come up here like this, okay. All right, so this Lewis structure, okay. But unfortunately, okay, so that's the wrong Lewis structure, okay. Okay, so if you use the method one, okay. So today we will learn another method, okay. So the method two, okay. And based on method two, okay, so you should able to draw the right Lewis structure for this one, okay. All right. Okay, so for the method two, okay, so we do the following step, okay. So yeah, we still use this one as example, okay. So first, kind of draw Lewis structure for all the atoms, okay. So yeah, actually that's not hard, okay. So yeah, atom, okay. So we have kind of nitrogen, okay. So we just kind of put the atomic symbols, okay, in the center and surrounded by Lewis surrounded by kind of valence electrons, okay. So if you cannot remember how many valence electrons for individual atoms, okay. Look at the periodic table, okay. So group number same as kind of valence electrons, okay. All right, so we have nitrogen, oxygen from group 6, okay, 6 valence electrons, okay, and then 3 the hydrogens, okay, 3 hydrogen, each has one electron, okay. All right, step 2, connect non-hydrogen kind of atoms, okay, so connect nitrogen and also oxygen, okay. So we build up bond, okay, so nitrogen contribute 1 electrons, oxygen contribute 1 electrons, okay. All right. And then step 3, okay, so fill remaining valence electrons, okay, with the hydrogens, okay. So lone pair electrons you don't need the fill it because they already kind of fill with electrons. So we fill kind of long electrons, okay, so single electrons, okay, with hydrogens, okay. All right, 3 hydrogen, okay. So one go to kind of oxygen, another 2 give to the hydrogen. So that give you kind of the right structure for the H3O, okay. All right. And so why the left one is right, the right one is wrong, okay, I will give you explanation later, okay. Okay, yeah, so if you have any question, okay, please type in chat window, okay, so yeah. Okay, so now, so for this one, okay, after you done the structures, okay, so make sure check the octet rule, okay, so whether say kind of whether all atom kind of surrounded by 8 electrons, hydrogen by 2 electrons, okay. And for this one, okay, so the nitrogen, oxygen surrounded by 8 electrons, so that's done, okay. But if some atom not surrounded by 8 electrons, you have to shape share more electrons to get kind of double bond or triple bond, okay, and then follow octet rule. So that's use the CO2 as example, okay. So CO2, we draw the Lewis structure by method 1, okay. We can also draw the Lewis structure by method 2, okay. CO2, we have carbon surrounded by 4 valence electrons, okay. Oxygen surrounded by kind of 6 valence electrons, okay. We have 2 oxygens, okay. All right, and then falling kind of begin to build bond, okay. So just connect the the hydrogen atoms, okay. So carbon, definitely connect with 2 oxygens, okay. So that's on single electrons here. Okay, so carbon contribute 1 electrons, okay, and oxygen contribute another electrons, build bond, okay. So we do the same thing for another bond, okay. Right, and then afterwards, okay, so there's no hydrogen for this molecule, okay, and then but when we check it, we find kind of oxygen has 7 electrons, okay, and then carbon has kind of 6 electrons, okay, so 2 bonds, okay, so 4 electrons plus 2 lone electrons, okay. So that's all are not follow kind of octet rule, okay. So in this case, we have to share electrons, okay. So these electrons, okay, and these electrons go together, okay, we build up the one bond, okay. These electrons, okay, and also these electrons go together, build up another bond, okay. So that's can also give you the carbon dioxide kind of right Lewis structure. Right. So now you check it, okay, you find kind of all the atoms surrounded by 80 electrons, okay, everyone's happy, okay. So how about ion? Can we use the method to draw the ion Lewis structure? The answer is yes. Okay. And the casings kind of for ion cation 有 loose electrons and then anion 有 gain electrons. Okay. So which atom get electrons? Which atom lose electron? Okay. So that depends on kind of the electronegativities. Okay. Right. So we use some kind of CO3 K 2 minus 2 K as example. Okay. That's the carbonate the anion. Okay. Okay, so we have kind of the 1 carbon, okay, and then 3 oxygen, okay. All right, and so for the anion, okay, so keep in mind, okay, so you need add electrons, okay, so we have minus 2 here, okay, so that means for the neutral molecule, you have to add extra 2 electrons, okay, bring it to the negative 2, okay. All right, so that's kind of question. Okay, so which atom gonna pick up these 2 electrons? Okay, so that's here. Okay, so electronegativities. Okay, for the anion, okay, higher electronegativity atom pick up the electrons. Higher electronegativity pick up electrons. Okay, we go here. So that's here.
Can you repeat that?
Mind repeating what you just said, please?
Okay, so maybe I write down here. Okay, so anion. Okay. Higher electronegativity, okay, I use the electronegativity, okay, atom, okay, pick up electrons, okay, all right, so that's here, okay, all right, and so for the electronegative table, you can see kind of the oxygen 3.5, carbon 2.5, okay, oxygen definitely has higher electronegativity, okay. So in this case, okay, 2 of this oxygen, okay, because we have only 2 negative charge, okay. So we'll pick up electrons, okay. So I use this cross market, okay. Okay. So these 2 actually become kind of the O minus 1, okay. All right, and then 14 we can go ahead kind of draw its Lewis structure, okay. Put the carbon in the middle, okay. So carbon support kind of the 6 valence electrons, okay. And then with the first 2 oxygen, okay. Question.
We can't see what you're drawing.
Oh, I'm sorry. Okay. Yeah.
Thank you.
All right. Yeah. So put carbon in the middle, okay, and then we connect carbon with the 3 oxygens, okay. For the first 2, okay, so pretty easy, okay. So we just build up the bond, okay. And then that's the actual electrons. And then second one, okay, same thing. Still use the color pen. All right, and then last oxygen, okay, so we put the bond here, and then here, and then 1 electron, okay, here, okay. All right, so that's not done yet, okay, because this oxygen and also this carbon is kind of single electrons, okay, not follow tactile, okay, 7, and then this one also 7, okay. So we have the share electrons between these 2 atoms, okay. So this one go here, this one go here, okay, and then that's give it kind of the final structure, okay. I draw like this way, okay. Okay, so that's this oxygen, okay, and then 2 oxygen, another 2. All right, so that's not done yet, okay, because this is kind of ion, okay, you need to put it kind of in the bracket and then label the charge, okay. So that's give kind of the final the CO2 CO3 2 minus, okay. All right, so next kind of how about cation? That's R9, okay. So maybe I still write it down, okay. So for the cation, okay. So cation you lose electrons, okay. So that's give kind of positive charge, okay. So for cation, okay, lower electron negative atom, okay, lose electron, okay. So write it down, okay. Lower electron negative atom lose electrons, okay. Okay, lose electrons, okay. So I give you one example is still using the ammonium, okay. So ammonium, okay. So NH4 plus, okay. So yeah, again the first step, okay, still draw the Lewis structure for all the atom, okay. So yeah, nitrogen 5 valence electrons, okay, and then 4 hydrogen, okay. All right. So because that's positive charge, okay, so that means here one of the atom will lose electrons. That can give you kind of a positive charge, okay. All right. So we need to go back here, okay. So say which one lose electrons, okay. Nitrogen negative electron negativity 3.0, hydrogen 2.1, okay. Hydrogen has a lower electron negativity, okay. So that means here one of the hydrogen will lose the electrons, okay. So assuming the last one, okay, last one has no electrons, okay, that should be kind of the H plus, okay, so all right. And then following kind of just same thing, okay, so we connect all the kind of the no hydrogen atom, okay, there's no only one kind of nitrogen, no other the atoms, okay, so just kind of fill valence electrons with the hydrogens, okay, so here. All right, so first nitrogen will use its own the single electron connect bond with kind of first 3 hydrogens, okay. Yeah, use up these 3 electrons, okay. Right, and then there's kind of one actual hydrogen has no the electron inside, okay, but the lone pair electrons, okay, on the nitrogen can fill into the nitrogen kind of the empty orbitals, okay. So that can build an actual bond, okay. So that can give you kind of final ammonium kind of the Lewis structure, okay. All right, so that's not done yet. Again, okay, you need to put in the bracket, okay, and then label the charge. Okay. All right, so that's how do you use method 2 can draw the ion structure, okay, ion structures, okay. And let's see, okay, R9, okay, so high electronegativity atom pick up electrons, okay. Cation, okay, lower electronegativity atoms, okay, lose electrons, okay. All right, and there's one problem, okay. So like I said, kind of for both methods, okay, there's some kind of advantage and also disadvantage, okay. For some cases, okay, so the method 2, okay, cannot draw the right Lewis structure, okay. So give you one example is the ozone, okay, ozone kind of O3, okay, O3, okay. Ozone case, so if you use the method 2, okay, so should start with kind of like this, okay. So oxygen, 3 oxygen, okay. Yeah, each surrounded by 6 valence electrons, okay, like this, okay. And then method just step 2 is kind of connect all the kind of atoms, okay. So you build bond between the left oxygen with the middle oxygen, build bond between middle oxygen with kind of right oxygen. All right, and then looks like only middle oxygen has the 8 electrons, okay. Left oxygen and right oxygen only 7, okay. So not follow octet rule, okay. But how do you shift the electrons, okay? Make bond kind of make everyone happy, okay. So you cannot build bond between the 2 terminal oxygen. That's some triangle. That's not such kind of atom, okay. So that's pretty hard for the method of 2 draw the right structure, okay. But you can use method 1 to draw the right structure, okay. Method 1, remember, okay, first count the total valence electrons, okay. 6 oxygens, okay. So 3 oxygens, okay, and then each has kind of 6 valence electrons, okay, give you 18, okay. Right, and then next kind of connect 3 oxygens, okay. So the 2 bond we use up kind of 4 electrons, okay, and then give you kind of the 14 left, okay. All right, and then we put these 14 electrons, okay. First, okay, keep in mind, okay, onto outside kind of oxygen, left and right oxygens, okay. right? And then to here, to here, to here, and to here, to here, to here. Okay, so the two outside kind of oxygen pick up the 12 valence electrons. Okay, 12 electrons. Okay, and each has kind of the 6. Okay, so here. Okay, so that's here, and then to left. Okay, so the last two. Okay, you put in the middle oxygen. All right. Okay, so that's we use out all the kind of electrons. Okay. So next kind of you have the shaped electrons. Okay. So because the middle the oxygen surrounded only by 6 electrons. Okay. So doesn't matter. Okay. So can shift this pair of electrons we build up kind of all the bond. Okay. And then eventually give you kind of right structure. Okay. So that's should like this. Yeah. So that's the ozone kind of the Lewis structure. Okay. All right, so here comes question, okay? So student always ask me kind of okay, so Leo, okay, so looks like the both method has some advantage and some disadvantage, okay? So when do I should use method 1? When do I should use method 2? Okay, hard to say, okay? So when I was kind of undergrad student, I like using the method 2, okay? But when I become professor, I like use the method 1, okay? So really depends on situation, okay? So so I personally found, okay, so it's kind of personally find, okay, so if you have kind of star shape, okay, so okay, that's a pretty good question. I will answer your question later, okay. I will answer your question later, okay. Someone will ask, why do you put the double bond here, not here, okay. So I will answer your question probably like 20 minutes later, okay. Okay, so so if you have kind of star shape kind of the molecule, okay, so for example, okay, so like X, okay, so star shape, okay, so maybe 3 atom attached to the middle, atom, okay, or maybe something 4 atom, okay, so Y, or maybe 5, okay, so something like this, okay. So that's I call the star shape, okay. So method 1 kind of better way, okay. So that's always give kind of right Lewis structures, okay. But if you see some kind of more complicated structures, okay. So probably use the method 2, okay. So for example, okay, so if you have kind of this kind of structure, X, okay, and each with some atom attached to it, okay. So that's probably use the method 2 is kind of a better way, okay. That's right, okay. That's right, okay. Okay, so anyway, okay, so you can try both the method, okay, and so later I will show you another way to determine which is kind of a right Lewis structure or not, okay. All right, okay. So no switches at the bottom of the table. No, that doesn't make sense. So when you that's right, okay, because the octet rule, okay, so that's I come to next page, okay. After you draw the Lewis structures, okay, so you have to check the octet rule, okay, that's showed here, okay. So make sure that all the atom kind of surrounded, at least most electrons surrounded by kind of kind of 80 electrons, okay. And also check total valence the electron numbers, okay. So what's that mean, okay? So still, we just use kind of carbon dioxide, okay. The carbon dioxide, okay, totally kind of 4 from kind of the carbon and then 12 from kind of oxygen, okay. So that's kind of so 16 the electrons, okay, that's total valence electrons, okay. So all these 16 valence electrons, okay, you should find the resource, okay. So either from kind of lone pair electrons or from kind of bonds, okay. So that's 1, 2, 3, 4, 5, 6, 7, 8, okay. So we have 4 bonds, okay, so 4 lone pair electrons, totally 16 valence electrons, okay. So so that's the same number of the number of valence electrons won't change, okay. And also charge, okay. So the charge kind of make sure that you can label it, okay. So don't forget it, okay. And the one common mistake from students is some kind of forgot to label lone pair electrons. Okay, that's make sure you don't forget it. Okay, all right. And then next kind of come to important information about the bond number. Okay, bond number. Okay, so when your atom form kind of the molecule, especially kind of neutral molecule. Okay, so So here kind of neutral molecule. Okay. And different atom, okay, has different kind of the bond number. Okay, so they have kind of very specific bond number for different. Okay, so write it down here. Okay, so write down. Okay, so hydrogen. Okay, so normally build up only one bond. Okay, hydrogen. Okay, and then carbon normally build up kind of 4 bonds. Okay, so for this 4 bond, okay, can be 4 single bond or kind of the 1 double bond and then 2 single bond and then maybe 1 triple bond, 1 single bond, or maybe the last one should be kind of 2 double bond. Okay, right? So that's something can keep in mind. Okay, and then nitrogen. Okay, so normally build up kind of 3 bond. Okay, and then with 1 lone pair electrons. Okay, can be kind of 3 single bond. Okay, or be kind of the 1 double bond, 1 single bond, or 1 triple bond. Okay. Oxygen, okay, so normally build up kind of 2 bonds with 2 lone pair electrons. Okay, can be 2 double bond or can be 2 single bond and 1 double bond. Okay, and then for hydrogen, we know that kind of fluorine, chlorine, iodine, and the bromine. Okay, so only build up the 1 bond. Okay, all right. So that's the also that's key, very very important. Okay, so. Keep in mind only for neutral molecules. So if it's kind of charged species, cation or anion, okay, maybe a little bit of change. Okay, right. So that's also answer some question. Okay, from last time. Okay, some student kind of Joule structure. Remember the CCl2. Okay, okay. So why we Joule structure like this? Okay. We build up a CO double bond here, note here this one. Okay, so someone asked kind of why not kind of build here the CCl double bond. Okay, right. The reason for that kind of oxygen like form kind of double bond. Okay, so 2 bond. Okay, so and the chlorine normally kind of only 1 bond. Okay, so that's the reason. Okay, so later I'll give kind of more the detailed explanation. Okay, so why that's kind of bond numbers. Okay, so that's relate to kind of formal charge. Okay, right. So that's okay, keep in mind. Okay, hydrogen 1 bond, carbon 4 bond, nitrogen 3 bond. Okay, oxygen 2 bond, and then hydrogen 1 bond. Okay, so that's only true for kind of the neutral molecules. Some questions? Cornovia. Don't know what's the Cornovia. Okay, maybe kind of. Okay, so I said something. Okay, so someone please turn off your microphone. Okay, turn off your microphone. Okay.
Yo, Zach, turn your mic off.
Zach, hey, please turn your microphone. All right, so I mute Zach. Okay. All right, so we continue. Okay. Okay, so like I said, kind of most time we should all the atoms should follow octet. Okay, but there are some kind of exception. Okay, so there are some kind of exception. Okay, so if the elements kind of in the 3rd period or kind of beyond. Okay, 4th or kind of 5th. Okay, so because those atoms has have kind of d orbitals. Okay, so can hold more than 8 electrons. Okay, so in this case they may not the follow octet. Okay, so example showed here. Okay, Okay, so sulfur. Okay, so this is the dichlorosulfoxide. Okay, so this molecule. Okay, sulfur actually has the 10 electrons. Okay. Reason for that kind of the lone pair electron can be held in the lone d orbital in the sulfur. Okay, So that's here a little bit careful, okay? So yeah, when you see kind of sulfur and phosphorus or some kind of other atom, okay, beyond kind of here periodic 2, okay? So yeah, you can keep in mind, okay? So that's here may get more electrons around it, okay? So we'll do a little bit of practice in the discussion on Thursday, okay? So you'll see kind of these kind of situations, okay? And for the elements in the periodic 2, okay, actually not also always follow the octet rule, okay? So yeah. Only this five guys, okay, lithium, carbon, nitrogen, oxygen, fluorine, okay, always follow octet rule, okay, but some atom maybe not, okay. So example is boron, okay, boron, okay. So yeah, boron can this is kind of boring Lewis structure, okay. So boron has empty p orbital, okay. So and for the boron structure, okay, so you can see the boron has only 6 electrons around it, okay. So this is right structure for boron, okay. So yeah, and so that's unfortunately happened to it, okay. So not exactly follow octet rule, okay. So that's something please keep in mind, okay. All right. So next is the formal charge, okay. So formal charge kind of the way how to assign the charge on individual atoms, okay, in one molecule, maybe in kind of the ion, okay. So for the formal charge, the equation, okay. So showed like this, okay. All right. So first, okay. Formal charge equals kind of the valence electrons number, okay. Yeah, valence electron number, okay. Again, okay. So for the individual atom, okay. So if you don't remember its valence electron number, okay, please look at the periodic table, same as kind of its group number, okay. And then minus the half of shared electrons, okay. So shared electron actually kind of just bonding electrons, okay, bonding electrons, okay. Half, okay. So just kind of from bond, okay. So yeah, because the bond kind of electron not owned by individual atoms, okay. So yeah, you share the code kind of and then minus the old unshared electrons, okay. Number of electrons. So yeah, normally for the unshared electrons are from the lone pair electrons, okay. Yeah. Okay, so that's pretty easy to remember, okay. So yeah, and so we use still let's see kind of still use ozone as example, okay. So remember the ozone has this kind of the Lewis structure, okay. And pretty interesting, okay, for the ozone, okay. So all 3 oxygen have different the formal charge, okay. So we do it one by one, okay. For the last oxygen, okay. So the oxygen valence electron should be 6, okay. So minus kind of the half of shared electrons, okay. So we only share kind of 2 electrons, okay, from the bond, okay. So and then minus the old unshared electrons, 6 unshared electrons. That's give you kind of the minus 1, okay. So that means under the last electrons, okay, minus 1, okay. For the middle oxygen, okay, so do same thing, okay. So 6 valence electrons minus kind of the half of shared electrons, okay. Totally 6 the shared electrons because the one double bond, 1 single bond, okay. So yeah. And then minus the unshared electrons only 1 pair of electrons, okay. So that's give you kind of plus 1, okay. So 6 minus 6 divided by 2, that's 3, okay. 6 minus 3 minus 2 plus 1, okay. So that means the middle oxygen is kind of plus 1, okay. And then for the right oxygen, okay, so 6 valence electrons, minus half of shared electrons, okay, only 4 shared electrons because only 1 double bond, okay. All right, 4 electrons here, and then minus unshared electrons, okay, 2 lone pairs, okay, 4 electrons, okay. So that's give you kind of 0, okay. So that means for the right oxygen, you have kind of 0 formal charge, okay. So that's should be pretty easy to calculate it. Okay, so yeah. All right, so now we come back. Okay. All right. People ask kind of we're beginning with try to draw the Lewis structure for NH3O. Okay, so why this one is wrong, why this one kind of right? Okay, so if you do the formal charge calculation, you find kind of for nitrogen. Okay, so this one okay will +1. For the oxygen here, okay, will be -1. Okay, so that's the general kind of a huge kind of charge separation. Okay, and then for the organic molecule, okay, don't like kind of charge separation. Okay? They always want kind of get a kind of balance, okay, as neutral as possible. Okay, but for the right Lewis structure, okay, so this the nitrogen will have kind of formal charge 0, and the oxygen also has kind of formal charge 0. Okay, so that's why this is kind of wrong, this is right. Okay, and the similar situations kind of for the this guy. Okay, so remember, okay, so why we say kind of hydrogen 1 bond. Carbon 4 and nitrogen 3 and oxygen 2 and hydrogen kind of 1. Okay, so if you don't do this kind of bond, okay, so you won't get kind of formal charge 1. Okay, right? For example, okay, so if we draw kind of the Lewis structure for this one, okay, you'll find kind of this chlorine will have kind of formal charge +1. This oxygen will have kind of formal charge -1. Okay, and charge separation is always unfavored for the organic molecule. Okay. But for this one, okay, right, everyone should have kind of 0 charge. Okay. Okay, so that's so that's why the formal charge is kind of important. Okay, so for the you determine whether you get kind of right the formula or not. Okay, and if you have question, you type in chart window. Okay, and another thing kind of once you draw the if you can draw like 2 or 3 kind of maybe more kind of the Lewis structure. Okay, you can calculate their kind of formal charge. Okay, check which one kind of makes sense more. Okay, so that's the thing. Okay, and then total charge. Okay, that's right. Okay, so we try to arrange it kind of most the atom has 0 charge. Okay, so organic molecule don't want kind of charge separation. You don't want kind of some build up positive charge on one atom and then negative charge on another atom. Okay, right. That's right. Okay. Okay, and then total charge should be kind of sum of the formal charge. Okay, so for example, okay, so this the ozone O3. Okay, total charge 0. Okay, so you sum of the formal charge. Okay, +1, -1, 0. Okay, that's give kind of 0. Okay, so same thing for other anion, cation, whatever. Okay, so where's it over here? Okay, right. For example, kind of we practice
Chinese lady in the background's just been straight creeping this class the whole time.
Question. Okay.
It's his wife.
Dude, it's gotta be. Like,
She looks old.
they're definitely in an office.
Chill.
Maybe she teaches here too.
What? All right. Okay. So if you have questions, okay, please write type in the chat window. Okay. Please turn off your microphone. Okay. Music song. No. All right. Okay. So type in chat window. Okay. All right. Okay. So for example, this molecule. Okay. And so this oxygen 0, this carbon 0. Okay, and then these 2 oxygens kind of -1 each. Okay, so that's the total charge. Okay, so -2. Okay, all right. So that's again Q charge and those some kind of formal charge and also the total number of one electron or contact rule. Okay, so all right, resonance. Okay. So that's some kind of important thing. Okay, so let's also come to the ozone. Okay. Someone asked me kind of so why do you put kind of double bond kind of on the on the right, okay, not to the left? Okay. So actually kind of if I put to the left, also is right Lewis structure for this molecule. Okay. This one's also right. Okay. Right. So reason for that kind of for ozone, there are kind of not single Lewis structures represent kind of it's real structure. Okay, so both cannot actually right. Okay, and for the actual real structure is kind of hybrid for these two structures. Okay, so these two structures we call kind of resonance contributing structures. Okay. And what happens kind of the electron won't stay on one single the atoms, okay? It will kind of shift, okay? Right. So something like this, okay? So lone pair electrons on this oxygen, okay, and then goes here, okay, and build up kind of that bond, okay? So between these two oxygen, and then the share electrons, the bond electrons, okay, will give to these oxygens, okay, and then become kind of lone pair electrons, okay? For example, from this one here, and then this will be from original kind of the lone pair electron from the oxygen. Okay, and certainly you can do the reverse way. Okay, so shift this lone pair electron back, build out the bond, and then shift this the share electrons give kind of the oxygen on the right. Okay, and then give you back to this the structure. Okay, and pretty much like this. Okay, so normally we use the double head arrow connect all the resonance structure, okay, and then use curved arrow, okay. So you see kind of curved arrow show kind of movement of the electrons, okay. And so that's actually kind of pretty hard part of the organic chemistry. So far, okay. So in chapter 1, you don't need to worry about kind of resonance, okay, and we'll study more in chapter 3, okay. So probably we'll spend more than one lecture to study resonance structure, okay. And so for quiz 1, okay, so quiz 1 will be probably on Monday, next Monday, and we won't do any resonance, okay. So that means kind of even you don't need to study for the resonance, okay. So don't worry about it, okay. So all right. Okay, so far all the what's your time? Okay, so very likely I'll open the quiz 1 in Monday evening case, next Monday evening case. So probably from 8 to 11. Okay, so that's we'll talk about more in lecture on Friday. Okay, so what's carry and then what kind of practice quiz. Okay. Okay, so so far, Lewis structure we learned so far just kind of planar, okay. So just kind of totally like this planar structure, okay. But for the real the Lewis structure, okay. So real kind of organic molecule kind of structure should be kind of 3-dimensional, okay. So can be any kind of directions, okay. So now we have to learn one theory called the Weisper theory, okay, to predict kind of molecular structure, okay. So Weisper kind of theory is kind of abbreviation for valence shell electron pair repulsion, okay, and so that's very useful, okay. So to predict molecular kind of shapes, okay. So Weisper, okay, useful to kind of predict molecular shape, okay. And also can be used kind of give you bound angle information, okay. And then in that case help you predict kind of molecular kind of polarity, okay. So that's for the whole molecule, whether there kind of dipole moment for the whole molecule, okay. Right, so for the Weisper theory, okay, so first step, okay, you have to kind of count how many regions of electron density, okay, around the individual atom, okay. So what's your regions of electron density, okay? All right, so write it down, okay, write it down, okay. So one lone pair electrons, okay, equals to one, little bit up, one single bond equals to one double bond, okay. And also equals to one triple bond, okay. So that means kind of yeah, no matter how many kind of the bond, okay, single bond, double bond, and triple bond all count as one regions of electron density. Okay, so that's yeah, the please keep in mind. Okay, right. And next kind of yeah, the regions of electron density kind of yeah, the repair each other, they hit each other, they try to kind of push away each other kind of as far as possible. Okay, so in this case, yeah, we'll determine what kind of molecule shapes. Okay, right. Give you one example. Okay, so carbon dioxide. Okay. Carbon dioxide, we know it's kind of loose structure like this, okay? Right. So for the center, yeah, the carbon, okay, has yeah, only two regions of electron density, okay? So double bond count as one, okay? We have kind of yeah, two double bond, okay? So two double bond, okay, hit each other, kind of push away each other, okay? Eventually, okay, so yeah, you get kind of yeah, linear, yeah, structure, okay? Linear structure, okay? And then bond angle should be kind of yeah 180 degrees. Okay, so we are 180 degrees. Okay, right. And another example. Okay, so yeah, we can use the methane. Okay, CH4. Okay, CH4. Okay, so yeah, the carbon build up kind of yeah four single bond. Okay, with hydrogen. All right. And the four single bond, four regions electron densities, okay, so they push each other, okay, eventually reach the balance, okay, then kind of tetrahedron kind of molecular kind of shapes, okay. And the bond angle should be kind of the 109.5 degree, okay. Right, and the third example is kind of the ammonium, okay, ammonium, okay. Ammonium kind of pretty interesting case, so there's kind of lone pair electrons on the nitrogen, followed by kind of three single bond, okay. Connect with the hydrogen.
Can you move the paper up, please?
Oh, I'm sorry. Okay, need to open it up. Yeah, one lone pair, okay, and then plus three single bond, okay. Right. So yeah, still the four regions of electron density, okay. And then if I ask now the shapes of electron density, okay, so yeah, should be still tetrahedron, okay, because you need to count lone pair electron. But if I ask now the molecular shapes, okay, okay, so you only need to count kind of the bounded kind of atom, don't count lone pair electrons, okay. So for molecular shapes of the ammonium should be kind of trigonal pyramid, okay. Trigonal. Pyramid, pretty much like this, okay. Right. And then last example, kind of water, okay, a little bit higher. Oh yeah, that's kind of the third rule of the Vesper, okay. So normally speaking, kind of lone pair electrons repair other electron density kind of more than shared electrons, okay. So in other words, these lone pair electrons hit more, okay. So they want to take more space, okay, and then push down the kind of the other single bond, okay, and make this bond angle, okay. So H kind of less than 109.5, okay. So this real tetrahedron, okay, and so the bond angle should be kind of 107 degrees, okay. And then one more example, kind of water, okay. So H2O, okay. So water has this kind of structure, okay. Two single bond plus the two lone pair electrons, okay. So if I ask kind of the regions of triple pyramidal polar. Yes, okay. So for the polarity, probably will cover it kind of in the next lecture, okay. So so far you only need to know what's the molecular shapes, okay. Right. So for the water, okay. So because these two, if I ask kind of regions of electron density shapes, okay. So still kind of tetrahedron, okay. So because you need to count these two lone pair electrons, okay. But if I ask kind of molecular shapes, okay. So you only need to count kind of the atoms, okay, and then bond, okay. So that should be called kind of bent. Okay. And so because these two lone pair electrons kind of want to take more space, further push down kind of this OH single bond. Okay. and then the bond angle become kind of 105 degrees, okay, something like this. So the one key thing here, okay, so yeah, please yeah, keep in mind, okay. So yeah, during exam quiz, okay, so yeah, what's the question ask you for, okay? So it's ask on the shapes of electron density regions, okay. So if I ask for that, okay, so you need count kind of the lone pair electrons, okay. So for the low waters kind of waters the shapes of electron density, okay, should be tetrahedron, okay. But if I ask kind of the shapes of a molecule, okay, shape molecule, okay, you only need count kind of bond and also atom, okay. So yeah, in this case, water should be bent, okay. So that's the little bit careful, okay. Do you get it, okay? All right. Shapes electron density, okay. Shapes of electron density regions, okay. You need to count both lone pair electrons, okay, plus kind of bonded kind of electrons, okay. But if I ask now only shapes of molecule, okay, only bonded kind of the electrons, okay. All right, so yeah, here's just kind of how do you show the molecule kind of in the 3-dimensional, okay? So we use kind of solid wedge or the broken wedge called dash, okay? Solid wedge kind of indicate the bond come out of the page, okay, and towards you kind of the dash bond indicate kind of the bond point away from you, okay. An example showed here, this is the built-in, okay? So yeah, these two hydrogen, okay, actually kind of connected by solid wedge, okay, that's indicate kind of these two hydrogen point towards you, okay. And these two hydrogen case connect by the dash bond, okay. So that means kind of these two hydrogen point away from you, okay. And so yeah, for all the straight line, okay. So straight line bond, okay. So that means kind of those bonds are just kind of in the plane or in the paper. Okay. Right. And here's some most common electron density regions, okay, and also molecular shapes, okay. So if we are only two electron molecular densities, okay, so it should be kind of linear most time, okay. So yeah, for example, this here the carbon, okay, so yeah, the second carbon, okay, so has kind of a double bond and has one triple bond and one single bond, okay, two region electron density, okay. So yeah, 180 degrees bond angle, okay, linear, okay. 3 regions of electron density really depends how many lone pairs, how many bonds, okay. So yeah, if 3 single bond should be kind of trigonal planar, okay, trigonal planar 120 degrees, okay, bond angle, okay. And if it's kind of one lone pair, okay, 2 single bond, okay, and then should be kind of bent, okay, so yeah, less than 120 degrees, okay. For example, this center carbon should be kind of trigonal planar, okay, and then 120 degrees, okay. And the 4 regions of electron density, okay, really depends how many bonds, how many lone pair electrons, okay. 4 regions, okay, 4 bonds, okay, should be kind of tetrahedron, okay, and then 109.5 degree bond angle, okay. So if it's kind of 3 single bond and 1 lone pairs, okay, should be kind of trigonal pyramidal structures, okay, 107 degrees bond angle, okay. So if it's kind of 2 lone pairs, 2 single bond, okay, and that should be kind of bent, okay, and then the bond angle should be 105, okay, something, okay, so yeah. And then on, okay, so 5 regions of electron density and 6 regions of electron density, okay, you can get a more complicated situation, okay. Right, but good thing for you guys, okay. Probably yeah. So yeah, electron pair, okay. So that's keep in mind, okay. Include both the bond kind of electron pair, also lone pair electrons, okay. Yeah. Right, and then good thing for you guys, okay. So for our organic chemistry, okay, we only care about kind of up to 4 regions of electron density, okay, up to 4, okay. And so in other words, okay, so during exam quiz, okay, so yeah, if I ask kind of the molecular shapes, okay, or kind of regions of the electron density shapes, okay, so only up to 4 regions of electron density, okay, so yeah, 2, 3, 4, okay, 5, 6, I won't put into the exam quiz, okay, so but you can study it by yourself, okay, so that's kind of pretty useful for organic metallic molecule, okay, yeah, up to 4, okay, keep in mind, okay, up to 4, okay. No, okay. So water, this is no hydrogen, okay? Yeah, only 2 hydrogen, okay? 2 lone pairs, 2 hydrogens, okay? All right. Okay, I guess, yeah, that's it for today, okay? So, yeah, we will continue this chapter on Wednesday, okay? So, yeah, we should able to finish, yeah, chapter 1 on Wednesday and then start also, yeah, the chapter 2 on Wednesday, okay? All right, any other questions? Yeah, have a good day, okay?
Thank you. Have a good one.
Thank you.
Yeah, you too, okay? Thank you. Yeah, you don't turn anything kind of paper-based kind of lab report quiz during lab, okay? So we just avoid kind of cross-contamination, okay? So everything handing on kind of EduCat, okay? So electronic one, okay? I will grade kind of on EduCat and you check your grade on EduCat, okay? Yeah, no physical kind of the handing, okay? Yeah. All right, so water, I do it again, sorry, okay? So H2O, okay, so should be oxygen, okay, so you have 2 lone pair electrons, okay, so and then 2 single bond connect with hydrogen, okay. So if you look at here, if I ask you for the regions of electron density shapes, okay, so you need to count the lone pair electrons, okay. So 1, 2, 3, 4, okay. So 4 should be always the tetrahedron, okay. So yeah, tetrahedron for the regions of electron density shapes, okay. But if I ask kind of molecular shapes, okay, only count here the bonded atoms, okay. So this part, okay, that should be bent. And then the bond angle should be kind of here the 105, okay, yeah, degrees. Is that show us? How to connect other water molecule, okay? So last year will be chapter 2, information, okay, non-covalent bond kind of interaction, okay. So yeah, this just kind of it's a single molecule, okay. All right, quiz will be carried in kind of the evening, okay, because we have 2 lecture section, okay, so we have to do it together, okay. So probably next Monday, 8 to 11 p.m., okay. Yeah, thank you, okay, enjoy your day, you too, okay. Thanks.